Okay, so for the second method in solving the non-homogeneous second order linear equation is method of variation of parameter. Okay, so as we know, this method of variation of parameter is to determine a particular solution. What is particular solution? Okay, so we know that we have y equal to yh plus yp. Okay, so for yh is the homogeneous solution and yp is the particular solution. Okay, this method applies when the coefficient of the differential equation are a function of x, okay, which is this one. Okay, so this is what we want to find. Okay, obviously it can be solved non-homogeneous second order with a constant coefficient. Okay, so why we have this method of variation of parameter? Because in the first method, which is method of undetermined coefficient, we only can solve 4 cases, which is polynomial, exponential function, okay, sine and cos function, and also the sum and product of the case 1, case 2 and case 3. Okay, how about the case of fx when we deal with tangent x, secant x, 1 over x squared, ln x, sine ex, and so forth. Alright, okay, so for this method of variation of parameter, we can solve this type of fx including the case 1, case 2, case 3, case 4 in method of undetermined coefficient. Okay, so meaning that method of variation of parameter is widely used. Okay, so how we want to solve it? Okay, alright, so let's say this is our second order linear non-homogeneous equation. Okay, so the method here, okay, step 1, we need to identify a and fx. What is a? A is from here. And what is fx? This is our fx. Okay, so first we need to identify a and the fx. Okay, so we need to, step 2, we need to consider the homogeneous equation. Okay, choose y1 and y2. What is homogeneous equation? Okay, this is the homogeneous equation, the yh. Okay, so meaning that we need to solve using homogeneous equation. Alright, which is we need to consider the ay double prime plus by prime plus cy equal to 0. Okay, and then we will obtain the value of yh, which is y1 plus y2. Okay, so we have, like, for example, if m1 is not equal to m2, okay, let's look at the example. Okay, let's say if we have for m1 not equal to m2, so we obtain ae m1x plus be m2x. So meaning that we have this is the first term and then this will be the second term. Or let's say we have yh for m1 is equal to m2, so we will obtain a e. Okay, so m1 is 0, so we'll have a only, sorry for that. Okay, a plus b e mx, right? So we'll obtain, sorry, okay, we will obtain a e mx plus b s e mx, right? So our y1 will be the first term plus our y2 will be the second term. Or let's say the third cases for our yh is what is that? Exponent alpha x, okay, a cos beta x plus b sin beta x. Okay, so we just expand, we will obtain a exponent alpha x cos beta x plus e alpha x b e alpha x sin beta x. Okay, so we'll have the first term here is y1 and the second term here is y2. Okay, so that is y1 and y2 here. Okay, so after we determine y1 and y2, okay, we need to find the w. Okay, so what is w? W is equal to y1 multiply with y2 prime minus y2 multiply with y1 prime. Okay, so after we define y1 and y2, we need to look at for y1 prime and y2 prime. Okay, so then we can give the value for w. Okay, so what is w? Okay, what is w? Where we want to use this w? Okay, it is in step 4. Okay, we need to calculate for u and v, where the formula for u is equal to negative y2 fx over a w. Okay, and for v is equal to the integration of y1 fx, so this is the f here, over a w. Okay, so after we obtain u and v, basically our solution for yp here, the term of yp is given by u y1 plus v y2. Okay, this is the general solution for particular solution of the differential equation. Okay, alright, so that is our y.